Okay, so this example will involve the use of a supernode. Okay, now on the right here, I've given you a little three-step process for using supernodes in nodal analysis. Okay. So the first step here is to identify the supernode. Now, in this problem, I/O is going to be just some voltage over 2K. Now this voltage right here is going to be the voltage at this point in the circuit minus the voltage over here at this point. Now on the bottom it's just 0 volts because of the ground reference right here. So basically our mission becomes to find out the voltage at this node, because with that we can do this voltage minus 0 over 2K, and that's I/O. Now when you do nodal analysis at this node right here, there's a problem when it comes to describing the current that enters it right here. And this is why you use a supernode. Basically, a supernode is just taking two separate nodes, like these two right here, and it's treating them as one giant node. So here would be our supernode for this problem, which consists of the two nodes V1 and V2. Alright, now the constraint equation for this is going to be V2 minus V1 is equal to 12. If the polarity was switched like this, it would be V1 minus V2 is equal to 12. Alright, so here we go. The second step is to do nodal analysis at the supernode. So, at supernode, here we go. Current in is equal to current out. Okay, time to label the currents in here, so we'll say it's going from left to right over here, going down over here, then towards the right over here, all chosen arbitrarily. So the first current is going to be entering the node over here, so we'll do 6 minus V1 over 2K, and then everything else is leaving the supernode. So over here we have V1 minus 0 over 1K. I/O is going to be V2 minus 0 over 2K. Lastly, we have V2 minus negative 4 over 1K. And now it is math time. And that's V2. Now just real quick, when I went from V1 to V2 minus 12, I was doing the third step here, which is the substitution. And I was using the fact from this equation right here. So from the constraint equation, V1 is equal to V2 minus 12. Right? Okay, so now we can use that to solve for I/O. So I/O is going to be just, oops, a little bit messy, V2 minus 0 over 2K, or 5.67 volts over 2 kilo ohms, which is just 2.83 milliamps. And this right here would be your final answer.